Okay, hello everybody. My name is Nick Bennett, and this is the first lecture of Mechanical Design 2 for Autumn 2022 session. And we're going to start off today just with a bit of an introduction about the subject and what you can expect over the next 12 or so weeks. So, as the title suggests, this is a design subject. It follows on very loosely from some of the practical things and some of the learnings you had in Mechanical Design 1. But we're going to extend some of the technical work that you do and some of the theoretical stuff, and hopefully expand your understanding of those. And allow you to develop skills a little bit more to, for example, do a bit more relevant and detailed analysis. And the way that you'll get to kind of apply what you learn, well, it'll be tested in a couple of ways, but one of the ways will be to do a critique of some engineering work in particular, play a role in this subject, and we'll get onto that in just a minute. And there are also some other softer skills: communicating ideas, working on decisions, making justifications, and communicating those outcomes effectively and efficiently as well. In your case, writing a report. So there's a few things that will get you doing over the next 12 or so weeks. The subject learning objectives are listed here. I'm not going to go through all of them now. You can read them in your own time. But these are the things that we are hoping that you will gain and be able to do on successful completion of the subject. So these are the things really you need to achieve in order to pass the subject, and you'll demonstrate those by passing, hopefully, all of the assignments that will be set. And we'll talk about that in just a minute. So who are the people involved in the subject? There's a picture of me there when I was a little bit younger anyway. So as I said, I'm Nick Bennett. You can contact me. My email address is there. As things stand at the moment with the COVID situation, we're able to offer face-to-face meetings. So my office is in building 11 on the 9th floor of the mechanical engineering school area. And you can make an appointment to meet me if you need to, but please get in contact with me first if you want to discuss the subject. And I'll say a little bit more in a minute about actually the best ways to get in contact with us. So I'm giving this overview. I'll also be picking up the topics from week 7 until the end of the subject, largely around the finite element analysis parts of the subject. We also have, well, let me just say first actually a little bit about the structure. So you'll probably be aware by now, if you've looked at the timetable for this subject, that all of the lectures are going to be online based. So we don't have any lectures in lecture halls for this subject. And indeed, as far as I'm aware, that goes across the faculty and goes across the university. So we won't have any face-to-face lectures at the moment. Everything's online. And the way we're going to do things is to have the recordings of the lectures, which we've in most cases we already have recordings with the content, but at the same time we'll offer the opportunity for you to ask questions and stuff. So we have the timetable slots should we require them in order to do sessions around the lecture content and discuss things that arise. But yeah, I mean, just in case it isn't clear, so we don't have any lectures, no lecture halls assigned, and there'll be no face-to-face lectures for this subject. So I talked about weeks 1, weeks 7 to 12. Weeks 2 to 6, the content there is covered by Dr. Paul Walker, who some of you might know. Paul is unfortunately not with us at UTS anymore, but we're still going to use the lectures that he's prepared for us, because they're very good. He has good expertise on the machine element topics, so we will we'll still take advantage of that. So those videos will be made available. Paul isn't contactable, of course, but if you have questions on those and the content, then I'm the person to ask about those, or you can ask in the relevant tutorials as well, and we'll say a little bit about that in just a minute. At the end, actually, I should say in week 12, the idea is actually not for me to give the lecture, is for Dr. Michael Behrens who's part of UTS Rapido, to give kind of a kind of case study, an industry case study of kind of applying mechanical design, the mechanical design approach to a real product. And this is a product that he's kind of taken to market. You can see an image of it there. It's kind of a, well, I won't say too much about it, but it's a wheelchair that's able to climb up steps. Obviously, steps are a bit of an obstacle for most wheelchairs. So Michael came up with, I believe this was during his PhD at UTS. He came up with a solution to this, and that's what he'll talk about. So he'll talk about some of the design challenges that he had, you know, and some of the things that he had to overcome to get to this point. And you know, so we're taking things a little bit away from the just looking at things from the textbook and the equations, and looking at more real world examples. So Michael will join us week 12. We also have two tutors on this subject as well. You'll see tutorials start in week 2. So we don't have tutorials this week, but they start in week 2. And we don't have tutorials in week 11 either. Look at the timetable for tutorials because they are, the weeks there are reflected accurately, at least the last time I checked the timetable. But the two tutors are Ahmed and Amer. So Ahmed will lead the tutorials through weeks 2 to 6, the first 5 weeks, which will be the tutorials on machine elements. So the gears, the clutches, the shafts, the pulleys, these topics. Amer will take over from week 7 through to 11. He'll work through the tutorials on the finite element analysis. Yeah, these are the guys to speak to. If you have questions on the tutorial material, even if you're not in the tutorial, if you're watching the tutorial online, for example, you can still contact the tutors. Their email addresses are here, and get in touch with them. One thing I will say, when it comes to contacting us, I'd really encourage you to use the discussion boards within Canvas. They're a really good resource, and they're probably better than firing lots of emails at the teaching staff, because, for example, we have 130 students on the course on the subject. So if you've got a question, there's a likelihood one of those other 130 people have the question. And I can tell you quite often I get asked the same question several times. So the discussion boards are great because you can ask a question, I can reply, and then other people see, okay, someone asked a question about the JEDR report, section 1. Okay, it's the same question I have, and there's the answer. Likewise, it's really good because as much as we try to respond immediately and as quickly as we can, sometimes you know, I don't reply within the first hour, but Ahmed might answer within the first hour, or Amer might answer, or indeed one of your classmates might know the answer and give the answer very quickly. So it works on a couple of levels. So I'd really encourage you to use the discussion boards within Canvas. I'm going to kind of set the precedent there this week by kind of putting up starting a discussion on week 1 questions. So that's more on the housekeeping side of things. If you have a question about, oh, who do we need to contact about this, or what room is this in, or I couldn't find something on Canvas where it should be, you know, this is the sort of things to ask this week. So please do that, and don't feel afraid to post a discussion topic. The discussion topic is there for you guys. I'm not reading it, policing it, saying, oh, these guys are asking lots of questions. You know, it's for you guys, and it's for your benefit, and it can be really beneficial. So please do use it, and don't be afraid to do that. If you have a question, just put it up there. And likewise, if you know the answer to a question, please post the answer as well. Even if you think it might be wrong, again, you don't get any marks. And unfortunately, if you answer the question, you don't get more marks. If you answer the discussion question with the wrong answer, you know, you don't get penalized. So please, let's try to be interactive, help each other out with this where we can. Okay, so onto the topics. Yeah, we're going to start off, as I said, looking at the machine elements. So we'll talk, essentially it does kind of break down as about a week on each of these topics. and you'll see that as the weekly kind of material is released. So we talk about gears and gearing, some of the underpinning equations, underpinning theory, and then some of the applications, things to consider, things like points of failure and stuff like that. We then talk about friction devices, pulleys, brakes, clutches, shafts is another example, and springs. And some of these topics are bigger, smaller than others, but we cover them in sufficient detail. We'll also talk about mechanisms, and we'll also talk, before we get on to FEA, in week 7 about optimization. I won't say too much about that now, but that also has a role in the assignment that you're going to do. In fact, all of these things do. We give you the material, and then we obviously want you to learn the material and get some practice with the material, and then we test you on your understanding. In the FEA part, the second half, there'll be some fundamentals about what FEA is actually doing, because it can be used a little bit like a black box where you just sort of get an answer out and, maybe that's right, but maybe it isn't. And there's a bit of necessary understanding to actually know what's going on. So we'll talk about that, and we'll talk about how you can test for things as well, like whether the simulation is working. So things like looking for convergence in your simulations, in your models. And we'll talk about various other things as well, and some different examples, which we'll go into later in the subject. So I've mentioned assessments. When it comes to assessments, there's kind of a couple of components to it, I suppose. So the first one is quizzes. You'll have to do 5 marked quizzes during the subject. Each one of those is worth 10% of your final mark, and there'll be one on elements, machine elements. There'll be 2 on machine elements, one in week 4 and one in week 6. There'll be one related to the JDR, which is the Junior Engineer Design Report, which we'll say a little bit about in just a moment. So one related actually to that report. That quiz will be due to be done in week 8. There'll be one on the optimization and mechanisms part due in week 10, and there'll be one right at the end of the subject as well during week 12, which will be on the finite element analysis, and that's more on the theory side, because you'll get a chance to display your hands-on competencies. And that'll happen in the other 2 assignment reports. So that makes up the other 50%, of course, 25% each. One of them is on the Junior Engineering Design Report, and one of those on an FEA report. The Junior Engineering Design Report, the deadline for that is in week 8. Exact deadlines will be, you can find them in Canvas. They'll be there clear when you go to click on get the information about the assignments. The deadline will be part of what's given to you. So look for the exact deadlines there if you want to know exactly what day and exactly what minute the submission closes. So yeah, 2 there. So the Junior Engineering Design Report, effectively, this is a kind of fictional report done by a junior engineer within a fictional company. So they've designed a machine, and the machine contains all the elements, coincidentally, that you're going to be studying during this subject. So there's pulleys there, there's gears, there's shafts, there's a clutch, I think there's some brakes, there's some gears as well. Some things in that design report are well chosen, others are less well chosen. There's some definite errors and mistakes in all sorts of things there, and your job really is to appraise that, is to go through and critique the design and basically comment on that. So if there are, for example, mistakes in calculations, we want you to correct those. What are the correct calculations? What equation should have been used, or what's gone wrong in the numbers, in the actual arithmetic? And then, to assess how does this affect the design decisions that were made, and what could have been done better. So that's effectively what you need to do in that one. To find out about that one, there is an assignment section within Canvas, and there'll be, I think there's about 4 or 5 PDFs that you need to look at. So one of them is the Junior Engineer Design Report. That's pretty crucial. It's pretty long. I think it's about 60 pages. So you need to read that sort of more than once. You'll also get quite a detail on the actual assignment, what you need to do and what the assignment should look like in terms of, you know, the sort of format that you might consider. We'll also give you a rubric, so you know roughly where the mark, or actually fairly specifically where the marks are, what you get your marks for, what you need to cover. So you can find that there and go through those PDFs, and you'll get a lot of guidance on what to do. So you need to spend some time reading that. That's clear. There's, you know, 5 documents, as I said. One's the 50, 60-page report, and all the documents, there are a few pages. So you need to take some time, and I will encourage you to do that soon, basically this week. And I'll say a bit more in a minute about that. The FEA is not dissimilar, actually. So in that case, you need to, it follows on from the JDR report, and you take part of what you've kind of redesigned in the JDR, or the design you considered, and you do some FEA analysis on that. And we want you to report on the results of what you find and comment on that. So it leads on from the JDR report. Again, there are instructions within Canvas, within that assignment, on what you need to do. So please have a look at that as well, and ask if anything's not clear. But hopefully the ideas are, sorry, what we want is relatively clear. And I should say as well, there's also a couple of activities, some exercises that we get you to do also as the first part of that one, which are effectively their tasks within the SolidWorks package that you'll use. So you'll work through those, and you'll get some time in the tutorial and be able to get some guidance on those as well if you need it to get going, that part of the assignment. A couple of things else to say. So that makes 100%, 5 quizzes, 10% each, and 2 assignment reports, 25% each. That's 100%, no final exam. So yeah, it's all assignment based. Other thing to say actually is to jump back a bit to the quizzes. The quizzes used to be done under exam conditions in exam halls. COVID's changed our approach to that a bit, so we're now doing everything entirely online through UTS Online. And we used to, obviously, you know, these were done in an exam hall, so we had a set exam time. We don't do that anymore. We've made that a lot more flexible, and so you don't necessarily need to be in Sydney to do these. You can do these from anywhere in the world. So what you need to do is log into Canvas, and you'll find the quiz. You know, it'll open at a certain time, it'll close at a certain time, and you do the quiz online through UTS Online. It's open book, so you know, if you want to search Google for the answers, you can do that. I don't think that's the best way to do it. You know, they probably refer to your notes, but these quizzes have always been open book, even when they were in under exam conditions. So there's no real advantage doing it now to doing it previously. In terms of the deadlines, so I've said there'll be one in week 4, week 6, week 8, week 10. These quizzes will open for a week each. So when one opens, it'll be open, haven't decided the exact day yet, but it'll be open, say, on a Monday of week 4, and it'll close the following Monday, exactly a week after. So you get a week to do it, you log in when you want to do it, and you do it at a convenient time for you. There's no set time. Yeah, I think that's everything on that. Again, if it's not clear, you can get in touch with me, or maybe post a message in the quizzes. Sorry, not in the quiz, in the discussion board about quizzes, and then other people get the answer as well if they have the same question as you. Just a quick thing on quizzes, on practice quizzes, sorry. We will have some practice quizzes available. So these will be on the same topics. It'll be very clear what's the practice quiz and what's the real quiz. But the idea is there that as Canvas is relatively new at UTS, you get some exposure to how the quizzes work, you know, actually the logistics of it. So, you know, when it starts, when it ends, what it does, when you press a button, what happens. That's the one part. And the other part is that you'll get an idea of the sorts of questions you might get asked when the real quiz happens. So do use the practice quizzes. They're marked in the sense that you get to know the answers, but they don't contribute to your mark at all. So I don't look at those. So use them as you want. I think you get unlimited chances to answer those quizzes. So yeah, use those and benefit from the practice. I think that's everything on assessment. I'll come back if I think of anything else. So how we'll handle the lectures and how you will be best going about the lectures, and not everyone will do this, but how you'd be best to do it, I think, is before the lecture, and you'll know what the topic is, but before you come to the lecture, or you view the video more like, you should read the JDR report and the section that's relevant to the topic of the day. So you can see the little machine picture here. You can see pulleys there, for example. If the topic is pulleys or if the topic's gears, have a look at the JDR report and have a look about what you need to actually do in your assignment relevant to gears, for example. And then just ask yourself a few questions like, is the use appropriate? So are gears in the right place in the machine? Should something else have been used in their place? Have they been used? What analysis was done? What equations were used? And if they weren't the correct equations, then what are the correct equations? If the equations were applied, were they applied correctly? Is the arithmetic right? What are the things like failures? What are the possible points of failure? Has that been considered, and has it been considered correctly? And has enough been done? Is there further analysis required? And then based on all of that, maybe the choice is made and maybe the use is spot on in your opinion, and that's fine. There will be some of those that it's not all complete nonsense in this engineering report. But if there are things, maybe mistakes or things that were overlooked, what modifications are required, and what do you need to kind of know? What do you need to get out of the lecture? So then when you go through the lecture video, you should be looking for where the information is that you need to answer the questions that are in the assessment. So we'll go over some of the theory, and there'll be some examples and some well, I wouldn't say interactive in the video, but there's some examples and chances to do some examples and learn and apply some of the theory, for example. After the lecture, then you can go back and say, okay, well, now I know what underpins this, and you'll hopefully have all the answers you need. If you don't, you've got the chance to speak to the lecturer. You've also got the chance to do a bit more practice in the tutorials, and you can speak to the tutors as well if you're unclear about what you need to do on a particular section. You can also ask your peers, and you can also post questions in the discussion board as well if you want to open questions up to other people as well. So that's how I would do it. And doing these on a weekly basis is a good idea, even if they're available earlier than that. I wouldn't leave it all till the end, but maybe some people will. But I think doing this in a weekly way is a good way to do it. There's also a quiz 0. And this sits somewhere, I suppose, between the quizzes, the real quizzes, and the practice quizzes. So quiz 0 isn't marked, but it is something we'd like you to do. And it's there just to kind of give you a little bit of a push to actually read the Junior Engineering Design report this week. So it's a kind of a quiz just to get you started and think about the right sort of questions that you should be asking when you're reading it. So it's essentially a quiz on what is the report describing, what's the purpose of the device, what are the specifications that it needs to achieve, do you see any obvious issues, do you agree with assumptions? Just to get you thinking about those sorts of questions that you're going to need to ask about all the elements along the way. And the third question there, ask the specifications clear, is particularly important because you know, if something isn't clear as well, you can get the clarification at this early point. So please do quiz 0 and do it this week. And yeah, that kind of brings me on to what to do this week. So this little mini lecture that you're watching now, I don't know how long it's taking, but it's probably only about 25 minutes. You have a 2-hour lecture slot here. You also don't have a tutorial this week, but please don't switch this off and think, okay, great, that's that done. What I'd really like you to do in your time this week in that 2 hours, 3 hours, is to make sure you're clear on everything that's required of you for the subject. Then have a look on Canvas, check all the general stuff, like you have access to Canvas is a good starting point. But please then have a look at things like the assignments. So look at the information that's there on the Junior Engineering Design Report, assignment 1. And please spend some time then have a look at the report, because it's kind of crucial to this subject that you read through that and you have a look at what you're going to have to get assessed on for that part. So please have a look at that, and then once you've done that and you've had a good read of it, read back through some bits a couple of times perhaps, then have a go at quiz 0 as well. And that's kind of the minimum task really for this week that we'd like you to work on. If you have any questions as well, you can post them in the discussion board or get in contact with me. But please do that this week, and then when the content, you know, the technical content begins next week, you'll hopefully be in a good position to start working towards the assessments that you need to do and the learnings that you want to get out of this. So I think that's everything. I might have missed 1 or 2 things. If there's any questions, you know, I've said it a few times, so I'm definitely encouraging it. So post something in the discussion. And yeah, I look forward to meeting most of you, I hope, during this session. And the best of luck with the subject.